Hello everyone, welcome to my channel. My name is Vidya and in today's video I am going to discuss the concept of Euler's Totient. Euler's Totient is a concept which is extensively used in cryptographic algorithms. One such algorithm is RSA, public key encryption algorithm. Now before you understand what is Euler Totient, it is very important that you also know the concept of prime and relatively prime numbers. I have already covered the concept of prime number and its significance in cryptography in my previous video. However, in this video we shall be covering the following topics. We'll first understand the difference between prime and co-prime numbers. We shall then go ahead to see the method to check if a number is co-prime to another number. We'll then understand the concept of Euler Totient, followed by the formula that is used to compute the Euler Totient. I shall cover the numericals on Euler Totient in my next video. So let us now move ahead to understand the difference between prime number and relatively prime number, or which are also called as co-prime numbers. Now, prime number has been covered in detail in my previous video. However, here I will do a quick revision on what is prime number. So, a number is prime if it is divisible only by two numbers. It should be divisible by 1 and by itself. Any number satisfies this condition, that is, it is divisible only by two numbers by 1 and itself. Such numbers are called as prime. For example, if you see 2, 3, 5, 7 and 11, if you divide it by 1 and if you divide it by itself, the remainder is 0. But if you divide these numbers with any other number other than 1 and itself, you will get some remainder, or you will get a fractional number, and hence these numbers are prime numbers. So what is a relatively prime number or a co-prime number? A number A is relatively prime, or which we also call it as co-prime, to another number B if it satisfies the following condition. What is it? The greatest common divisor of A and B has to be 1. So if this condition is satisfied, then A and B are said to be relatively prime numbers or co-prime numbers. So two numbers are said to be relatively prime if the greatest common divisor of the two numbers, that is GCD of A comma B, is equal to 1. So let us understand what is co-prime number with the help of examples. So let us first take this example, that is, we have to check if 2 and 5 are co-prime. Now if you check these two numbers 2 and 5, the common divisor of 2 and 5 is only 1. There is no other number which divides 2 and 5. So the greatest common divisor of 2 and 5 is 1. Hence 2 and 5 are relatively prime numbers, or they are called as co-prime numbers. Now let us check another example. What about number 2 and 6? Are they co-prime? So if you check the common divisor of 2 and 6, 2 and 6 can be divided by 1, 2 and 6 can be divided by 2. So which is the greatest common divisor? It is 2. So the greatest common divisor of 2 and 6 is 2. So since the greatest common divisor of 2 and 6 is not equal to 1, we'll conclude that 2 and 6 are not relatively prime or are not co-prime numbers. So let us check few more examples. What about number 12 and 13? Are they co-prime? So if you check the common divisors of 12 and 13, 12 and 13 can be divided by a common divisor 1. 12 and 13 does not have any other common divisor. Therefore, the greatest common divisor of 12 and 13 is 1. And hence, because it satisfies the condition, that is GCD of A comma B is 1, hence 12 and 13 are co-prime numbers. Let us check one more example. What about 12 and 16? So if you see the common divisor between 12 and 16, the number 12 and 16 can be divided by 1, it can be divided by 2 and 4. So your GCD, that is greatest common divisor between 12 and 16, is 4. And since the GCD between 12 and 16 is not equal to 1, 12 and 16 are not co-prime numbers. So guys, I hope you understood the concept of co-prime numbers. Now we move ahead to understand what is the concept of Euler's Totient. So first and foremost, Euler Totient is represented by a standard universal symbol called as phi of n, where is a number whose Euler Totient has to be computed. computed. Okay, now what is Euler totient? I will come to that point a little later, but before that, let us just take one example. Let us focus on this question. Find the count of numbers which are relatively prime to 9. So if you want to find the numbers which are relatively prime to 9, what is the condition you are going to check? The condition that you have to check is the GCD between that number n and 9 has to be 1. So you have to check whether the number n satisfies the given condition or not. And what is n? N are numbers between 1 to 8. Now why only till 8? Because 9 is not divisible by number larger than 9 itself. So the last number with which you can divide 9 is 9 itself. If you try to divide 9 with 10, 11, 12, since they are larger numbers, you will get a remainder or you will get a fractional number. So 9 is not divisible by numbers which are larger than 9, or any number is not divisible by number larger than itself, and hence we do not test the numbers larger than n. We will check only from 1 to n minus 1. Okay, so with this background, let us now try to find the count of numbers which are relatively prime to 9, for which we have to check the following condition, and with n varying from 1 to 8. So now let us do that. So if you check the GCD between 1 and 9, so the common divisor between 1 and 9 itself is 1, and hence 1 and 9 are co-prime numbers. Let us now check GCD between 2 and 9. So the common divisor itself between 2 and 9 is 1. There is no other common divisor between 2 and 9. Therefore 2 and 9 are co-prime numbers. Now let us check GCD of 3 and 9. So if the common divisor between 3 and 9 are 1 and 3, therefore the GCD of 3 and 9 is 3, and since GCD of 3 and 9 is not equal to 1, 3 and 9 are not co-prime numbers. Then let us now check the GCD of 4 and 9. So the only common divisor between 4 and 9 is 1. There is no other common divisor, and hence 4 and 9 are co-prime numbers. Let us now check the GCD between 5 and 9. So the only common divisor between 5 and 9 is 1. Therefore 5 and 9 are co-prime numbers. Let us now check the GCD between 6 and 9. So if you see 6 and 9, they can be divided by 1, they can be divided by 3. So the greatest common divisor between 6 and 9 is equal to 3 and not 1, and hence 6 and 9 are not co-prime numbers. What about 7 and 9? The only common divisor between 7 and 9 is 1, and hence they are co-prime numbers. What about 8 and 9? Since the only common divisor between 8 and 9 is 1, 8 and 9 are co-prime numbers. Now, what was the goal of this question? We wanted to count the number of relatively prime numbers to number 9. So what is the count of numbers which are relatively prime to 9? So let us count that. So we have 1, 2, 3 and 9 are not co-prime. So 4 and 9 are co-prime. So 3, 5 and 9 are co-prime. So 4, 6 and 9 are not co-prime. 7 and 9 are co-prime. So 5 and 8 and 9 are co-prime. So 6. So we have 6 numbers that are relatively prime to number 9. So the final answer to the given question are, we have 6 numbers that are relatively prime to number 9. However, as you can see here, in order to find the answer, we had to compute the GCD of numbers ranging from 1 to n minus 1. Now here 9 is a small number, so you were able to do it in 6 lines. But if you are checking for a larger number, it becomes computationally lengthy, it becomes computationally intensive to do this, and hence the easier way rather than checking GCD is to use Euler totient. So what is Euler's totient? Euler's totient, which is denoted as phi of n, basically gives us the count of numbers which are relatively prime to n. So what is n in this case? N is 9. From the steps that we just solved before, we saw that the count of numbers relatively prime to 9 was 6. Therefore, if you try to use a formula and find Euler totient of 9, you will get the answer 6. And what is the formula for Euler Totient and how to solve the numerical, I'll be teaching you in the coming video. However, after computing the Euler Totient of 9, the answer will be 6. And what does it indicate? It indicates that there are in total 6 numbers between 1 to 8 which are relatively prime to 9. So this is the information provided by Euler's Totient. Euler's Totient of n gives us the count of numbers which are relatively prime to n. Okay, so let us see one more example. Let us say I want to find the count of numbers relatively prime to 20. That means I want to find phi of 20. However, we will use the traditional method of doing it. Now, what is the traditional method? Traditional method says that you have to check GCD of number n with respect to 20, and if it is 1, then in that case n and 20 are co-prime numbers. And what is n that you are going to check? N are numbers from 1 to 19 in this case. Let us now check out the traditional method. So the GCD between 1 and 20, there is no other common divisor between 1 and 20 other than 1. So 1 and 20 are co-prime numbers. Then if you check the GCD between 2 and 20, as you know, the common divisor between 2 and 20 is not only 1 but it is also 2, and therefore the greatest common divisor is 2, and since it is not 1, 2 and 20 are not co-prime numbers. Now let us check GCD between 3 and 20. So 3 and 20 share only one common divisor, which is 1. So they are co-prime numbers. What about GCD between 4 and 20? So if you check the common divisor between 4 and 20, you have 1. They can be divided by 2. They can be divided by 4. So the GCD between 4 and 20 turns out to be 4, and since it is not 1, it is not a co-prime number. What about GCD between 5 and 20? Again, 5 and 20 can be divided by many numbers other than 1. So since GCD is not 1, it is not co-prime number. What about GCD between 6 and 20? Again, 6 and 20 have many common divisors other than 1. So since GCD is not 1, it is not a co-prime number. What about GCD between 7 and 20? 7 and 20 can be divided only by one common divisor, which is 1, and hence 7 and 20 is co-prime. What about GCD between 8 and 20? So 8 and 20 share many common divisors other than 1, and hence since GCD between 8 and 20 is not equal to 1, they are not co-prime or relatively prime numbers. Now, what about GCD between 9 and 20? 9 and 20 share only one common divisor, that is 1. There is no other common divisor for 9 and 20, and hence 9 and 20 are co-prime. What about greatest common divisor between 10 and 20? 10 and 20 have many common divisors other than 1. So the greatest common divisor is not 1, and hence 10 and 20 are not co-prime. What about GCD between 11 to 20? So 11 and 20 have only one common divisor, which is 1, and hence they are co-prime. GCD between 12 and 20? 12 and 20 share many common divisors other than 1, and since the greatest common divisor is not 1, 12 and 20 are not co-prime. So what is the GCD between 13 and 20? It is 1. So 13 and 20 are co-prime. GCD between 14 and 20. 14 and 20 can be divided by many other numbers other than 1. So GCD is not 1, and hence 14 and 20 is not co-prime. What about GCD between 15 and 20? 15 and 20 can be divided by many other numbers other than 1, and hence GCD is not equal to 1, and hence it is not co-prime. So what about 16? GCD between 16 and 20 is not equal to 1 because there are many common divisors other than 1. So 16 and 20 are not co-prime numbers. Then we'll check number 17. 17 and 20 have only one common divisor, which is 1. Therefore GCD of 17 and 20 is 1. So 17 and 20 is co-prime. What about GCD between 18 and 20? It is definitely not 1 because 18 and 20 share many common divisors other than 1, and 18 and 20 are not co-prime numbers. And the GCD between 19 and 20 is equal to 1. there is no common divisor between 19 and 20 other than 1. So greatest common divisor of 19 and 20 is 1. Therefore 19 and 20 are co-prime numbers. Now the question that we were focusing on is to find the count of numbers that are relatively prime to number 20, and we were doing traditional method. So we computed the GCD. Now we have to count how many numbers between 1 to 19 have resulted in GCD of 1. So let us count that: 1, 2, 3, 4, 5, 6, 7 and 8. Therefore we have got total 8 numbers which are relatively prime to 20. And which are they? They are 1, 3, 7, 9, 11, 13, 17 and 19. So we got in all 8 numbers which are relatively prime to 20. But note, this is a traditional method of doing it, where you had to check the GCD of each and every number. Now here in this case 20 is a small number, so it was possible for you to do it. But instead of 20 you have been given a large number, then in that case the number of steps required to check the GCD of each and every number will be very large. The computation becomes more tedious, and hence the easier way of doing it is to use Euler Totient. Euler Totient, which is phi of n, provides us with the count of numbers that are relatively prime to n. So you can just apply a quick formula and get the final answer. Now what is the formula? I'll discuss it in the next slide. So for example, in this case, if I would have computed Euler Totient of 20, I will get the answer as 8. So without going for the traditional method, that is computing the GCD of each number with respect to 20 and testing if it is 1 or not, rather than doing it, you can directly use formula of Euler Totient and get the final answer. So let us now check out the formula to compute the Euler Totient of any number n. It is also denoted as phi of n. Let us see the formula in the category of 3 types of numbers. In first category, the number is a prime number. In second, we consider composite number, and in third we consider the number to be a power of prime number. So if n is prime, the formula of Euler Totient is given as n minus 1. If it is composite, composite means n is made up of 2 prime numbers. P and Q are prime numbers, and composite number is multiplication of 2 prime numbers. In that case, the Euler Totient is given as P minus 1 into Q minus 1. Now, what do you mean by power of prime number? So, if P is prime number, so N is power of prime number. So, P raised to the power of E. So if n is represented as power of prime number, that is p raised to the power of e, in that case the Euler Totient is computed by formula p raised to e minus p raised to e minus 1. Okay. Therefore, there are 3 formulas which you should know. If n is prime, you will use phi of n is equal to n minus 1. If n is a composite number made up of multiplication of 2 prime numbers p and q, you will find phi n as p minus 1 into q minus 1. And if the number n is power of prime number, that is n can be represented as p raised to the power of e, where p is a prime number, then you will use the formula p raised to e minus p raised to e minus 1. So using these formulas, we will now solve numericals in our next video. So before that, kindly note that in order to check relatively prime numbers or co-prime number, the condition that we were testing is GCD between a comma b is equal to 1. So you can check this condition quite easily by using a theorem which is called as Fermat's theorem or Euler's theorem, which we will do in our coming videos. Note students, there is a difference between Euler's Totient and Euler's theorem. Euler's Totient is used to give us the count of numbers which are relatively prime to a number n, while Euler's theorem is a theorem or is an algorithm which is used to check if the greatest common divisor between a and b is 1. So with that, we come to end of this video. So thank you guys. Thank you for listening to my video. I hope it was useful to you. So coming up in my next video, I will be solving numericals on Euler Totient. So see you guys. Stay happy, stay blessed.